Okay, picture this. You're waiting for the text, the one that decides everything. Did you get the job? Did they say yes? Is the party still on? This message is a huge deal. It's going to make your year, or it could totally wreck your week. You feel your phone buzz in your pocket, you pull it out, your heart is racing, you're ready to see what it says, but then bam! The screen is black. The battery is completely dead. It's just a dead black rectangle in your hand. Right now, in this exact moment, you are living two lives. Seriously, think about it. In one life, you got the good news. You're already celebrating in your head. Who you're going to call first, what you're going to post online, high fives and victory dances. That life is real. It's a possibility. But at the same time, another life is happening. The bad news life. You're already feeling the disappointment, bracing for the letdown, thinking about your backup plan. Both outcomes are sitting there, waiting for you. Two totally opposite futures. One is amazing, the other sucks. They're both kind of happening at once inside your head. They exist together in this weird, tense space of pure potential. Your future is literally split in two. All because you can't see that one text. Good ending, bad ending. Both floating there, equally possible. The only thing separating you from one of those futures is a little bit of battery life. It sounds insane, right? But this is actually a real thing. This is where it gets crazy. It's a real-life version of a weird idea in science. A famous thought experiment that messes with your head. Until you look, something can exist in multiple states at once. The universe hasn't made up its mind. Your good life and your bad life are waiting for you to pick one. And you don't even get to choose. You just have to look. Your universe is about to collapse, and it's all because of one text. All right, let's talk about the guy who came up with this wild idea. His name was Erwin Schrödinger. He was this super smart physicist back in the day, and he cooked up this thought experiment that people still argue about. You've probably heard of it. It's called Schrödinger's cat. It sounds like some weird cartoon, but it was his way of showing how bizarre the rules of the tiny quantum world really are. He wanted to point out how ridiculous it would be if we applied those same rules to our big, everyday world. Here's the setup. It's simple, but it'll bend your brain. Imagine you have a steel box. You can't see inside it at all. Inside this box, you place a cat. This is just a thought experiment. No cats were actually harmed. Along with the cat, there's this little gadget. It contains a single radioactive atom, a tiny, tiny particle. Now this atom has a 50-50 chance of decaying within 1 hour. It's a total coin flip. If the atom decays, it triggers a hammer which smashes a vial of poison and, well, the cat dies. But if the atom doesn't decay, nothing happens. The hammer doesn't fall, the poison stays sealed, and the cat is totally fine. So, after 1 hour, you have two possible outcomes. Either the cat is alive, or the cat is dead. In our normal world, we just say we don't know which one it is until we open the box. It's one or the other. We just have to check. But that's not what the crazy quantum rules say. This is where it gets weird. According to the laws of quantum mechanics, that tiny atom isn't just one thing or the other. Until it's measured or observed, it's in a state of both decaying and not decaying at the same time. It's a blur of both possibilities. So if the atom is linked to the cat's fate, then the cat is also in a blur of states. The cat is both dead and alive, simultaneously. It's not one or the other. It's both. The live cat and the dead cat exist together in the same box, at the same time, until someone lifts the lid to check. Schrödinger thought this was completely absurd, and that was his whole point. Okay, forget the cat. Let's be real. Nobody has a radioactive cat box. But we all have phones. Remember that dead phone and the life-changing text message? The phone is the box. The text message is the cat. Until you power it on and read it, your life is in superposition. You are both the person who got amazing news and the person who got terrible news. Imagine a split screen playing both movies at once. Left side, you getting the good news. Text on phone, you got the job. You jump up and down. You scream with excitement. You call your best friend. The friend screams too. You make plans to celebrate tonight. Music is upbeat and loud. That's timeline A. Right side, you getting the bad news. Text on phone. Sorry, we went with someone else. Your face drops. You sink onto the couch. You stare at the wall. You put your phone face down and sit in silence. Colors are muted. Only a quiet fridge hum. That's timeline B. Both movies are playing at once. You star in both. Until you charge the phone, you are both the hero of the party story and the main character of the sad couch story. Reading the text will make one a reality and the other a what if. You are literally holding two versions of your life in your hands. Section 5. The double slit. How watching changes everything. So why do scientists even believe this crazy superposition stuff? It's not just a wild guess. It comes from a real experiment that is maybe even weirder than the cat story. It's called the double slit experiment. It's super famous and it's the foundation of all this quantum weirdness. Imagine you have a tiny paint gun that shoots single electrons one by one. You're aiming it at a wall. In between, a barrier with two little vertical slits. If you set up a detector to watch which slit each electron goes through, they act like tiny balls. Some left, some right, and they make two straight lines. Simple. But if you turn the detectors off, wrong to expect two lines. Instead, you get an interference pattern, many lines, like waves passing two openings. When no one is looking, each single electron acts like a wave and somehow goes through both slits at the same time. This is huge. It's what actually happens. The particle is in a superposition of going through the left slit and the right slit. It interferes with itself. Only when you try to measure it, when you observe it, does the wave-like behavior disappear and it snaps back to a single slit. This experiment proves the two core ideas. 1. Tiny things can be in multiple states at once, superposition. And 2. The act of observing forces them to pick just one state. Watching changes the game. This is the big question that Schrödinger was really asking with his cat story. Okay, we get it. Tiny little electrons and atoms can be in two places at once. They can be waves and particles. They live in this weird, fuzzy world of possibilities until we look at them. Fine. But where does that stop? At what point do things stop being fuzzy and start being real and solid? Is there a line where the weird rules turn off? This is called the measurement problem. Think about it. You are made of atoms. Your phone is made of atoms. The cat is made of atoms. Everything is. So if the atoms that make up the cat can be in a superposition, why can't the whole cat? Why have you never seen a cat that's a fuzzy blur of alive and dead? Why have you never seen a basketball go through two hoops at the same time? There must be some kind of boundary. Most scientists today have an idea for this called decoherence. It's a complicated word for a pretty simple idea. As soon as a quantum particle interacts with its environment, like bumping into air molecules or photons of light, its superposition gets destroyed almost instantly. For a single electron in a vacuum, you can keep it in that fuzzy state. But for something as big as a cat, made of trillions of atoms constantly interacting, the superposition would collapse in a fraction of a second. The environment is constantly measuring the cat. The information about its state instantly leaks out into the world, forcing it into one reality. The world itself is the observer. This solves the paradox in a practical way. The weird rules apply to everything. But for big objects, they cancel out so fast we never see them. But it's still a mind bender. It suggests our solid, predictable reality is only solid and predictable because it's constantly being observed by everything around it. So let's go back to you and your phone. You finally found a charger. You plug it in. You watch as the little battery icon appears on the black screen. That moment, right there, is everything. The suspense is killing you. The phone boots up. You see the notification banner for the text message. Your finger hovers over the screen. You're about to do it. You are about to perform an observation. You are about to force the universe to make a choice. This is the moment physicists call the collapse of the wave function. It's a dramatic name for a simple action: looking. The wave function is just the mathematical description of all the possibilities. The split-screen video of your good life. The split-screen video of your bad life. The spinning coin. The cat alive. The cat dead. It holds all the potential outcomes together in one fuzzy, probabilistic wave. But that wave can't last forever. When you interact with it, when you measure it, the wave collapses. It transforms from a sea of possibilities into a single, concrete fact. All the other potential outcomes just vanish. You take a deep breath, and you tap the screen. Shatter. That's the feeling. It's like a glass sphere containing two different worlds just shattered, leaving only one behind. The split screen in your mind disappears. One side goes black forever. The other side becomes your entire reality. The text message appears. It's either good news or bad news. There is no more maybe. There is no more both. There is only what is. You have collapsed the possibilities into a single definite outcome just by looking. This moment of collapse is one of the biggest mysteries in physics. What actually happens? Does our consciousness cause the collapse? Does the measuring device do it? Or does it just happen naturally? Nobody has the final answer, but we can feel it. We feel it when we open an important email, when we turn over the final card, when we finally read that text message. It's the instant when all the what-ifs and could-bes die, and the one single, unchangeable truth is born. Thoughtful. Some physicists say the cat is both. They say when you open the box, the universe splits. It's called the many worlds interpretation. This idea says there is no collapse. The wave function never shatters. Every time a quantum measurement is made, the universe splits into branches. So when you open that text, the universe literally splits in two. In one reality, you go celebrate. In the other, you sit on the couch. Both universes are real. You just can't reach the other you. Every decision, every collapse, births a new reality. Quantum rules apply to everything, without exception. So what's in your box? A promotion? A rejection? The terrifying truth of Schrödinger's cat is this: uncertainty is potential. The moment you look, you lose every other possibility. Now tell me in the comments, if you had a Schrödinger's text, would you open it?